Map, CompactMap, and FlatMap are all very similar in that they can transform a sequence of elements like an array or a dictionary or a set, run some logic on each of those objects, and then return it into a brand new sequence of elements. I was a little bit confused about when and where I should be using map, CompactMap, and FlatMap, so I came up with some examples that I'm going to share with you now. So here is one of the use cases that's pretty common to use map. And basically what I did is I created a movie struct with a couple of details. Then I created an array of those movies. And now let's just say I have a view that I want to pass in the a list of the movie titles, right? It doesn't make sense for me to pass in all of the movie objects. I just want an array of the movie titles, which is a string. So if we're not using the map feature, here's one way you could do it. Create a function where we are looping through our array of movies, appending the movie title for each, and then returning that array of movie title strings. And then, of course, running the function here so that we get our array of movies. So you can see that it works totally fine, and it's a fine solution, except for the fact that it's a lot more code than is really necessary for something that can be done a lot simpler with map. So I'm going to get rid of this. And instead of running this function, what we're going to do is we're going to call our movies and .map. We're going to open up a closure here, and we're just going to call, we're going to call $0 right? And when we hit print, we're going to get the same result that we had when we ran our function. Basically, what's happening is that when we're calling map, we're asking for it to transform this list in some way. Now, we didn't really perform a transformation, but all we did was we created a new array based on the movie title. And the $0 is basically what that means is, like our for loop, it's iterating over our array of movies. $0 is just meaning like the first object and then the next object and the next object, and it's pulling out those titles and then, of course, returning it as an array of strings. So that's one way you could use map, just to simply pull out information from a larger set of data into a much smaller, much more condensed set of data. Now here is an example of transforming it. Right? So we have an array of doubles. We're going to call this distance in miles. And let's say we want the same array, but we want that distance to be in kilometers. We want to create a conversion of those miles to kilometers. So we'll say let distances in kilometers. And instead of creating a function and doing it like that, we'll just say let distances in miles dot map. And we're just going to say $0 times 1.609, which I believe is the correct conversion rate. And now when we say print our distances in kilometers, we're going to get an array of our kilometers that have been converted from miles. Right, so it's performing that transformation and then returning it back into an array for us to use however we want. So here's an example where you might want to use CompactMap. So we have an array of integers. We're calling this employee IDs, and I've created a function here just to demonstrate what is actually happening. In this function, we are passing in an integer, so we're going to be passing in each of these. And we're going to be returning an optional string. So in the case that it's 0 to 100, we're going to return entry level, associate, executive, or whatever number that it is. In the case that it's the employee ID is not any of those numbers, we're going to return a nil value. So it may be there, it may not, but when we call our map function, you'll see we'll say let's employee titles is employee ID dot map, and we're just going to pass in our function here, return title with our ID, and you'll see print employee titles you'll see now, because we're returning an optional value, we're going to get an array of optional strings. We're getting optional executive, optional associate, entry level, and of course our lost value, because we didn't account for it in our function, is a nil value. So that's fine if you don't care about having optionals, you don't care about, maybe you want to know if you have nil values there, but let's say we don't want that. We just want an array of our strings. Well, this is a chance for us to use CompactMap, and all CompactMap really means is that we're applying the same transformation that we did in map, but we are going to condense and consolidate, unwrap all of those optional values and discard any nil values, so that when we execute that code, what we get back is simply an array of our strings. All right, so that is why you might want to use CompactMap. And the last one is FlatMap. So going back to FlatMap or CompactMap again, remember we were passing in a non-optional value of integer, and we were returning an optional value of string. Now in FlatMap, just to demonstrate this process, this is just a trivial function just for the sake of explanation, but this time we're returning an optional double and we're passing in an optional double, so that's a double optional. Now I've also created a optional double here just to demonstrate what would happen if you were to use a map transformation with something that has a double optional like that. So we'll say let new distance equals our distance dot map, and again we're going to pass in our function that we created here. We'll say calculate distance $0, and now when we go to print this, you should see here in our log or on Xcode, expression implicitly coerced from double question mark. So this basically means, normally it would be a double question mark, which is an optional, but with a double question mark, that means a double optional. When we hit print, you'll see in our console here that we now have a value of optional 1.89. So that is an inner layer of optional and an outer layer of optional, which is problematic. We cannot use this with the typical map function. It probably means that we are doing something wrong. Maybe what we could do is unwrap our value here before passing it in, just so we can not have a double optional. That becomes a nightmare to work with. So instead of using map for this, we can use FlatMap, and what that will do is it will unwrap the outermost layer of optional, returning us with a single layer of optional, and that way it becomes workable again. We can use this code again, and now you can see the output here is an optional 1.89. All right, so that is a few uses of how you can use map, a few use cases for them, and I hope you enjoyed, and thank you for watching.